gonna try, or we will, find out how you find the vertex of a quadratic equation. Okay, so quadratic equations, they either open up and the vertex V is the lowest point, or it opens downward and the vertex is the highest point. What is the vertex? Well, let us assume for a moment that the parabola does have roots. Say the roots are A and the roots are B. Now, let's look better at the quadratic equation. And due to symmetry, that x value is going to be a plus b over 2. It's going to be a plus b over 2. And even if the graph went this way, that highest point, due to symmetry, is going to be right in the middle of a and b. Now, let us look at the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2. Let's find the average of the two roots. Well, one root is negative b plus or minus, plus b squared minus 4ac over 2. And the other root is negative b minus the square root of b squared minus 4ac over 2a. Well, let us add them and divide by 2. That will give me the average. Well, so let us just add the numerators. So it's going to be over 2, that 2. So we're adding and we have common denominators. Well, if you add something and then you take it away, it's gone. So what we have is negative b over 2 plus negative b over 2. That is, we have 2 times negative b over 2. And please, let's not forget to divide by that 2. Oh, excuse me. How can I make this mistake? You divide by 2a. You divide by 2a. So when you add those two fractions above this line, you get 2 times negative b over 2a. So let's not forget to divide by 2. And this is the average of their two roots. And this cancels out and you get negative b over 2a. And we'll call this x sub b. It's the x value of the vertex if it has roots. But what happens if it doesn't have roots? My goodness. What if it's positive? Always positive. How do you find this? So this is y equals to, in general, ax squared plus bx plus c. Well, so here is the vertex. Nobody's going to argue with this. Now, if you brought the graph down, maybe you took away 7, and now the graph looks like that. It's still going to have the same x value. It's still going to have the same exact x value. But we know what the x value of this is. It's negative b over 2a. We know what the x value for that function is. We took away enough to make it come negative. Okay? So the vertex of this new function, the one where out of nowhere we lowered it, has that x value, but they have the same x values. The original one also has that. Likewise, if the graph is a negative quadratic, how do we find the average of the two roots? Well, maybe this one is ax squared plus bx plus c. That's this one. Well, you know what? I'm going to add enough so it goes above. So this one will be y equals ax squared plus bx plus c, and I add positive b. That is, this distance is always d. I raise every point d. Well, we have that root, which is negative b plus the square root of b squared minus 4a over 2a. And this root, which is negative b plus, this one is the minus. This one is the minus. This is less. This number is less than that number. We have negative b plus, to make it bigger, b squared minus 4ac over 2a. And the value in the middle is just going to be negative b over 2a. That's for this one. But you know what? This has the same x value for the vertex. Just because we brought this point straight up doesn't mean that they don't have, doesn't mean they're not, it does mean they're going to have the same x value. This x value right here is negative b over 2a, and this, call the function f of x. And the y value will be f of negative b over 2a. That is, that one you're going to have to compute more rigorously. The f of negative b over 2a. And this point will definitely have negative b over 2a as the x value. And if you find f of negative b over 2a, that would be just this part. You better add d to that y value. And now you have the formula for the x value of the vertex. So the vertex is always going to be at negative b over 2a, and if the function is called f, it's going to be f of negative b over 2a. X, comma y. When you take f of an x value, you get a y value. If this is 9, if f of x is 9, then y is 9. If f of x is 11, then y is 11. I never said that when this is 11, I never said x is 11. I said all of this is 11. F for some number is 11. Okay, from this equation, can you tell me what x is, or can you tell me what y is? Well, this mess equals y, and this mess equals 11. Therefore, y is 11. Okay. So we argued why the vertex is what it is. But now, let's do this same thing using calculus, for those of you who know it. If f of x is ax squared plus bx plus c, and we want to find the max or the min, now either it goes this way or it goes that way. So there's only going to be one max or min. Now, the derivative, and it's always going to be at the vertex. The derivative is 2ax plus b. And we want to set this derivative to 0 to find the max and the min. We'll bring the b over. So 2ax is negative b. Now, we divide by what we don't want here. We only want x, so we divide both sides by our 2a, and there's the x value of the vertex. So the vertex will be at negative b over 2a, and I call the function f, and the y value will always be f of the x value. And as you notice, that was a bit quicker, so go and study calculus so you can do this stuff more easily.